All right, welcome back. In this video, we're going to be working Algebra 2 Quiz 1.4, which is going to be some graphing inequalities, some more solving inequalities, lots of inequalities. Okay, so the first question is, let f be f of x equals 2x plus 5. When is f of x greater than or equal to 0? Well, I've got a formula for f of x. I'm just going to plug it in right there and say, okay, 2x plus 5 needs to be greater than or equal to 0. Okay, and then I'm going to solve for x. And I'm going to start by subtracting 5 from both sides, and then dividing by 2 on both sides. I've got my red pen over here. And so I'll say, all right, x is going to need to be greater than or equal to negative 5 divided by 2. That's the values of x, right? That's good enough. Okay. Now, if we've got two functions, g of x and h of x, and we want to know when is g less than h, this is a very common math thing to do. When is one function less than another? Okay, well, we've got a formula for g of x. That's x minus 6. It's going to be less than the formula for h of x, 7 minus 4x. And then we're just going to kind of try to solve that x. I might try to get rid of this negative 4x by adding 4x to both sides. So x plus 4x would be 5x. And I'm going to add 6 to both sides. I'll have 5x less than 13. And then I'll be ready to solve at x by dividing both sides of this inequality by 5. And dividing both sides by 5, that's not a problem. If I was divided by negative 5, that would reverse the direction of the inequality, but I'm not, right? I only have positive 5 here, so I'm just going to divide by that positive 5. And I'll say that x is less than 13 divided by 5. Okay, number 3. Write a linear inequality in x and y that describes the region shown in the figure below. All right. I think I'm noticing that the slope is equal, or the intercept is equal to 7. If it goes through the point 0, 7 and the point 4, 0, I'm going to have to use the slope formula to figure out the slope there. It's not just like even. So the slope is going to be y2 minus y1, 7 minus 0 over x2 minus x1, 0 minus 4. That's negative 7/4. Okay, that makes sense. It's negative. Looks pretty steep. Negative 7/4 could be it. Okay, so I know if this was the equation, it would be y equals negative 7/4 x plus 7. But this is an inequality. I see there's shading below, so it's going to be a less than. And since this is a dotted line, it's going to be strictly less than. And so that will be, I just want to make sure that's clearly a 7, not a negative 1/4. Okay. And that's an inequality in x and y that represents the region shown in the figure below. Okay, number 4, give a sketch of the inequality on the axes provided. Okay, I think with this one, my advice to you is to, because of the negative 3y greater than, I think it's going to end up being a less than or equal to situation. I'm going to solve for y equals mx plus b, especially since we're only sketching. It doesn't have to be like super accurate with the intercepts. I'll label them eventually, but I'm going to solve for y. So I'm going to subtract 2x from both sides. And then I'm going to divide by negative 3. And that's where we have to be careful. We have to remember to reverse the direction of the inequality. So that becomes a less than or equal to. If I divide everything by negative 3, I'll have positive 2/3 x. 18 divided by negative 3, well, that's going to be negative 6. Okay. So I've got a y-intercept of negative 6. Let's say that's there. An x-intercept, that would be where 2x equals 18. Right, because y equals 0, so that'd be x equals 9, so that just needs to be a little bit bigger. But I'm going to draw the line, right, because this is a sketch. It doesn't have to be perfect. Okay, I drew it solid because it was less than or equal to. Had I drawn it solid in pen and then realized it was strictly less than, I'd have come back through with my eraser and, put some holes in that line to make it look a little dotted. Right? And if you make the same mistake, you're just going to have to come see me, and like during the quiz, during the test or something, quiz already passed, but if it happens during the test and you're on the line and you were in pen, you're just going to have to come see me, and I can come help you with that. So we're over here. We're where y is less than or equal to because of the negative 3 ended up reversing the direction. So we kind of shade down below here where y is more negative. And that's our solution region. But that's far enough. That's good. It's a decent catch. Okay. Anne works out with a treadmill program that varies the amount of time she runs and walks. She has the treadmill set to a walking speed of 80 meters per minute, a running speed of 240 meters per minute. I hope those are accurate. That seems maybe, yeah. The amount of time she spends running and walking can differ for every workout, but she always does a total of at least 4,800 meters. Okay, that at least means we're going to have like a greater than or equal to 4,800 somewhere. Okay, so we're going to write an inequality whose solution represents all possible combinations of x and y, x being number of minutes walking, y being number of minutes spent running during a workout. Oh, okay. So it's 80 meters per minute walking, and that's x. So 80 times the number of minutes spent walking plus 240 for every minute running, that is at least 4,800, right? Yeah, because we're talking about distance needs to be at least 4,800. Okay. And we can give a sketch for that inequality, right? We're not interested in any negative amounts of running or walking times. Okay. So we just got to figure out what the x and y intercepts are. Okay. So as far as what would I have to multiply 80 by to get 48, or to get 4,800, 8, 16, 24, 32. Oh, 8 times 6 is 48, okay? So, okay, 6 times 80 would be 480. So I need 60 times 80 is 4,800. So x-intercept is going to be 60. Okay, I'm going to just decide that the y-intercept is going to be, I'm going to just draw in my line. Use a straight edge anyway, but I'm just going to decide, since it's greater than or equal to, I know it's going to be a solid line, I'm going to draw it like that. Okay, that's going to be dropped. Oh, that was a bad pen anyway. Just throw it in the trash too. All right, and now I need to figure out, you know, what the y-intercept is going to be. And, all right, what is the y-intercept? Oh, what would I take 240 and multiply it by to get 4,800? Well, 24 times 2 is 48. 240 times 2, that's 480, so it's going to need to be 20. And then the inequality, well, it's like really everything where y is greater than or equal to, or, you know, you think about this line represents exactly 4,800 meters, and, you know, more time spent walking and running would give you more distance, so that's another reason why it's going to be this region up here. I'm only going to shade in what we would call the first quadrant, where x and y are both positive, but, you know, I mean, I suppose you could shade over here, but these are places that don't make a whole lot of sense because they've got negative amounts of time spent running, or negative amounts of time spent walking. That's not realistic, right? Okay, so find the x-intercept on the graph of my inequality and interpret its meaning in the context of the problem. Fortunately for me, I already computed that. If you hadn't, I will show you how we do that. The x-intercept is where y equals 0. And to go back to my inequality, that's 80x greater than or equal to 4,800. Really interested in where 80x equals 4,800. And then I divide both sides by 80, and I get x equals 60. Okay. And the meaning is, okay, well, that's y equals 0. Y is the amount of time. So if she spent 0 amount of time running, she always walks at least 60 minutes. Okay. Pardon me, I didn't realize I was off the screen. If no running, Anne walks for at least 60 minutes. The key would be 60 minutes walking, no minutes running. And then for the y-intercept, we're going to do the exact same thing. That's going to be x equaling 0. That would be where 240y equals 4,800. Okay, and that's y equals 20. And I would say that if she did no walking, she's going to run for at least 20 minutes. Okay, and that's all for Form A. Right, for Form B, okay, we've got a formula for f of x. Okay, f of x equals 2 minus 5x. We want to know where is f of x greater than or equal to 0, so we're just going to plug in using that formula. Okay, so 2 minus 5x represents f, and we want to know where that's greater than or equal to 0. I think really maybe f represents 2 minus 5x, but that's a different discussion for later in the course. Okay, we're going to start solving at this thing. I might add 5x to both sides because, you know, when possible, I would prefer not to divide both sides of an inequality by a negative number because I know I have to remember something when I do that, so I can just try to avoid that. And that won't be too hard, right? When I add 5x to both sides, and then I divide both sides by 5, I'll have 2 over 5 is greater than or equal to x. And in my class, that's your open response. You're safe to leave it like that. But we need to also be aware that this is the same inequality as x is less than or equal to 2/5. Uh-oh. That was pretty ugly, but you know what I'm saying. X is less than or equal to 2 over 5. All right, move on. Get that off. Yeah, get that out of sight. So we're going to say we've got a formula for g. We've got a formula for h. When is g less than h? Okay, we can do that. Okay, g is less than h. That means that 2x minus 6 is less than 7x plus 4. And now we're just going to start solving at x. I think I might subtract 2x from both sides. I might subtract 4 from both sides. I might divide both sides by 5. And if negative 2 is less than x, well, that's where x is greater than negative 2. Okay, now we've got write a linear inequality in x and y that describes the region shown in the figure here. Okay. So I've got an intercept of y-intercept of negative 4. So that's where x is 0 and y is negative 4. And then an x-intercept of 5, so that's where x is 5 and y is 0. Okay, I've got the slope, the intercept. I need to find the slope. Slope will equal y2 minus y1 divided by x2 minus x1. Okay, so that's going to be 4/5. The intercept is negative 4. So if this was an equation, the equation of the line, that would be y equals 4/5 of x minus 4. But I know that this is an inequality and we're shaded below, so that's where y is less. So it's y is less, and since it's a solid line and not a dotted line, it's less than or equal to. On the next one, we'll be wanting to give a sketch of the inequality. Okay, we can do that. 3x minus 2y is greater than 18. Solve for y. Okay, so negative 2y. I have to subtract 3x from both sides. But subtracting, no big deal on the inequality. It's dividing both sides or multiplying both sides of an inequality by a negative number that we have to be concerned about. And right now, there's really no way I'm going to get around it. I've just got to get at y, so I'm going to divide both sides by negative 2. So that will make that a less than. When I divide negative 3 by negative 2, that's positive 3/2. And 18 divided by negative 2, that's negative 9. Okay, so y equals 3/2 x minus 9. That would be a line like this, but its y is strictly less than, so I need to produce a dotted line here. And I'm just going to do the best I can. 3/2 is a somewhat steep slope. And if I'm not putting any scale in, it really doesn't matter. Y is less than, so I'm going to shade this area. Okay, I didn't have very much. Probably should have made negative 9, not so negative, but it's down here where y is less, so it's underneath the curve. That's pretty bad shading, but you know, you get the idea. It's below or to the right or whatever. Okay, let's flip over back. All right, Anne works out on a treadmill program that varies the amount of time she spends running and walking. Okay, walking speed is 70 meters per minute. Running speed is 200 meters per minute. So we're going to write an inequality that represents the combinations of x and y, where x is the number of minutes spent walking and y is the number of minutes spent running. Okay. The distance is always at least 2,800 meters. Okay. So something has got to be at least 2,800. But the total amount of distance, well, that would be 70 meters times the number of minutes spent walking, which we said is x, plus 200 times the number of minutes spent running, which is y. Okay, this is the total amount of distance she traveled, right? And that's got to be at least 2,800. So I'm going to say greater than or equal to, because at least 2,800 means 2,800 meters, that's okay. 2,799 meters, that's not enough for her. But 2,800, that's okay, and she could go farther, right? That's going to be greater than or equal to 2,800. Now I'll give a sketch of the graph of my inequality. Okay. I'm only interested in where x and y are positive because these are numbers of minutes spent running and walking. We're not going to spend -5 minutes running, right? That doesn't make any sense. So I could probably find the x-intercept is, okay, and I know the x, that worked the other form. I know that that's going to be the next two problems. We're going to have to figure out the x and y-intercept. So maybe I'll do those first and then come back on the sketch at the end. Okay, so the x-intercept on the graph, that's going to be where y is equal to 0. Okay, and so that'll be where 70x is equal to 2,800. And I think, well, 7 times 4 is 28. So 70 times 4 would be 280, which is off by a factor of 10. So x is going to need to equal 40. Okay. And, okay, well, I'm just going to just label that 40. And then for the y-intercept, go down a little bit, and I know that's where x is equal to 0. Okay, so if x is equal to 0, I have 200y greater than or equal to 2,800, but the intercept is just going to be on the line itself, so I'll be looking at 200y equals 2,800. Okay, so 2 times 14 is 28, so 200 times 14 would be 2,800. Okay. And so I'm saying y is going to need to equal 14. And so maybe I'll say it like that. Okay, I kind of made the mistake. I should have just drawn the line first and then labeled the intercept as 14. Just gone with it. But so now I have to bring in my straight edge to make it really nice. But I'm just going to do that this time. Because we're not interested in where x or y are negative, right? That's the domain of interest. Okay, I still haven't interpreted the meaning in the context of the problem, but now I've got a sketch of the inequality, except for the shading region. Okay, I have to think about, am I going to shade above or below? Okay, on one hand, you can say that the total distance needs to be at least 2,800. And this line, this is the set of points where the distance is equal to 2,800. Okay, and if you think, how do I go farther than 2,800? Spend more time running and walking, right? So that would be out here. And that's probably, I think, the best way to know that should be shading above. Also, you could go, kind of more algebraically and say, if I was to solve this for y, I wouldn't be dividing by any negative numbers. I'd subtract 70x and then divide by 200 or something. I would still have y is greater than or equal to, so I'm shading up there where y is greater. Now, as far as the meaning, well, this is if the amount of time spent running, that's y, is 0. Then the amount of time spent walking is at least 40. Okay? So I'm going to say if she doesn't run at all, and walks at least 40 minutes. Okay. And then the x-intercept is going to kind of be the opposite. The y-intercept is going to be the opposite. So that's where x is equal to 0. So if she doesn't do any walking, that's what x represents. She's going to be running at least 14 minutes. So Anne runs at least 14 minutes. Okay. And that's all for this quiz. Thanks for watching. Hope it helps. And, you know, if you're watching these videos to get ready for the Unit 1 test, I just want to reaffirm for you that this is the best way to prepare, is going back through the quizzes. So really, thank you for doing that. It will pay off for you.